Hey there, this is Math 2, Unit 8, Worksheet number 3, Simplify Exponential Expressions. So we're going to use exponents to fill in the blanks here. So because they have the same base, 3 plus something has to get me to 7. And in this case here, we would say 3 plus 4 gets you there, right? So 3 plus 4 gets you to 7 over there. Over here, we have 4 plus something gets you to 12. Same basis, we would say 8. 4 plus 8 gets you there. When we look at number 3, we have 2 plus something gets you to 11. We're probably going to go ahead and say let's do 9 because 2 plus 9 equals 11 there. So that's all pretty straightforward when you have the positive ones. When you get over here, now we want something that equals 1. Well, if you think, remember, anything to the 0 power is equal to 1. So let's make that equal to 0. If we have a positive 4 here, we make this a negative 4. And then that's all we have to do. Negative 4 plus 4 is equal to 0. So it becomes a to the 0 power, and we're set. We have a 12 on this side. We want to get down to 5, which means this needs to become a negative 7. So we have 12 minus 7 equals 5. And over here, if we want to have 2 left over, then this has to be equal to a negative 6, because 8 minus 6 is going to leave you with 2 left over right there. All right, looking at the next section. Find the value of x. Okay, well, let's rewrite this. Here, this is in like that fractional form, right? And here we have in radical form. So let's rewrite these as 15 to the 3/4 times 15 to the 6/4. The fourths comes from right there. That's where the 4 comes from. That's our denominator value. And here we have a 3 and the 6. Now, when I have the same base, what do we do with the exponents? We add them together. So 3 plus 6 is going to be equal to 9. The denominator stays the same. So 15 and 9/4 is equal to 15 and x/4. So what is the value of x? Well, you just look at, well, what's right here? If that equals that, so 9 equals x. You're just trying to find out, try to get it in the same kind of shape, the same form, and see which number is missing there. And that's how that works there. Same idea for number 9. Here we have 7 to the 4/3. And this one here is 7, and let's make it negative because it's on in the denominator. We have 6 for our numerator and 9 for our denominator. So I can't add those together quite yet because they don't have the same base, 3 and a 9. Okay, so I want to rewrite that. This I can reduce. 6/9 can be reduced to what? I can reduce that to 2/3. So let's rewrite this. 7 to the 4/3 times 7 to the negative 2/3. Again, my denominators are the same. So I have my base, denominators there. 4 minus 2 is 2. And my goal is to get into the form right here where it's 7 equals 7x over 3. So I have the 7s, the 3s, so what's my value of x? It's right there. 2 equals x, or x equals 2. All right? That's all you're doing there. And you will have ones like that on your tests as well, so kind of get used to setting that up the right way. Number 11. Simplify each expression and write the final answer using only positive exponents. All right, so first of all, with number 11, I see it's to the negative 3rd power, so I need to move the whole thing downstairs. This becomes 1 over 2x cubed. Okay, so we're not done yet. Let's continue. This becomes 2 cubed is 2 times 2 is 4 times 2 is 8. And the x is just staying x cubed, and we'll leave it like that. That's the idea there. For number 13, we have 3 to the 4th, m to the 4th, 6 squared, m squared. We can rewrite this a couple ways. We could say that 3 to the 4th, I could write the whole thing out, or I could say that it's 3 times 3 times 3 times 3, right? Follow me there? And here I have m to the 4th, which is 1, 2, 3, 4. I'm just going to do this the long way real quick, okay? And 6 squared is going to be 2 6s, right? So 6 times a 6. And m squared becomes m and an m. Well, 6 can be rewritten as what? 2 times 3, 2 times 3. Follow me there? So let's erase that, erase that. Now let's do some reducing. I can eliminate a 3, 3, an m, and an m. And what am I left with? I'm left with 3 times 3 is 9. I'm left with 2 m's up here, so m squared. On the bottom I have 2 times 2 is 4. So I could do it that way. That's kind of a long way of doing it, but that's kind of the idea of what you're after. If you did it by doing the mathematical way, again, 3 times 3 is 9, right? And then another 3 times 3 is 9, and 9 times 9 is 81. You'd end up with 81 m to the 4th over 36 m squared, and have to reduce that. This reduces pretty simply as the m squared, and then you'd have to do some kind of division work there to go, what's 81 over 36, common denominator, you'd still end up with 9 over 4. So again, lots of ways to go about it. Just showed you kind of the longer way of doing it in terms of breaking it apart, but it works. Here we have 21 m to the, well, let's do the m separate. Sorry about that. So we look at our whole numbers first of all. 21 over 3. That can reduce. 3 goes in here 7 times. So we know we have 7 on top. And for the m's, I have m to the 5/4 times m to the minus 1/4. And why is it minus? Because it's in the denominator, so I make a minus there. Because I have the same denominator, I can just simply add 5 minus 1, which is 4. So I get m to the 4 over 4 power, which means m to the first power is all I have left when it comes to the m's. For my whole numbers, all I had left was the 7, so I end up with 7m. And that's all I have left for that one. Is it on the right page? You can see it there. Oh, okay, got it. All right, cool. We'll flip it over to the back side. Let's take a look here at number 17. All right, right now we have all these negative exponent values here. I could rewrite it and flip them over if it helps you see it. You can do that way, or you don't have to do that way, but there are other ways. Let's just change around now just for now. The 3 and 21, I'm not too worried about that because we know that reduces down to a 1/7. So don't worry about the 3 and 21 for now. Let's change these around, the x values. So this is x to the -5th. Let's put that down here where it belongs. And here's x to the -8, which means I move it upstairs. This y to -2 moves downstairs. And the -9 has to move upstairs to make a +9. So if I was to rewrite the whole thing, I'd end up with it looking like that so far. Now I could go back to what I did before and do 8 minus 5, which is 3. It's a whole number 3. So we have x to the 3rd up on top. 9 minus 2, which is 7. So I have that up on top. And I still have my 1/7, which is 1/7, like so. Now, can you go about it a different way? You certainly could, right? You certainly could do that. If I looked at it like this is like -5 minus a -8. And -5 minus -8, that becomes a positive. And then 8 minus 5 equals 3. And because it's a positive, it's going to be on top, which it is. For the y's, it's a -2 minus a -9. Okay, and so in this case here, add those up, and then 9 minus 2 is 7, and so you're right there as well. So you could still do the addition subtraction stuff if you wanted to. Just what do you see? How does it make sense to you? If you want to change the order first and then solve, that might be easier for you. Just depends on what you see and what doesn't confuse you the most. Okay, so first I have number 19, I have my whole numbers here, -7 over 28. So that just reduces down to a 1/4. So I know I have a negative on the outside here, and I have a 1/4, no problem there. Here I have 3, for the A, I have 3 minus a -7, right? So 3 minus whatever is here, so I'm subtracting the difference. That becomes add, and 3 plus 7 is 10. Whole number, or positive number, so A is on top, A to the 10th. For the B, I have a -8 minus a -12. Subtracting a negative becomes a positive. So 12 minus 8 equals 4. So B is also going to be on top, B to the 4th there. I wrote it a little funny. I probably should rewrite it a little nicer. We have negative a to the 10th, b to the 4th over 4. And that's probably what it looked like, more like a proper answer here. Okay? And I just put the negative on the outside to the fraction. The whole thing is negative. It's not like a top or bottom. It's just a negative fraction. Okay? 21. Here we have this mess to the negative 4th power. Okay? So I could, first of all, what I could do is I could do some reducing. I could worry about this last, in a sense. I could say this is really 2 to the, what's 4 minus 2? 4 minus 2 is 2. So I have 2 to the m squared power and all that to the negative 4th. Because it's negative 4th, I'm going to drop it to the denominator, the whole thing. And that becomes 1 over 2m squared to the 4th power. So now I put the 4th into the 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So that becomes 16 there. And then with the m, we multiply. 2 times 4 is 8. And we have m to the 8th power, like so. Number 23. All right, 23. We're going to go ahead and multiply some stuff out here. Let's do that first. We have 3 cubed, which is 27. For the m, it's 1/2 times 3, which is 3 over 2. All right, when I multiply that together. Down below, this is 1/2, which is the square root of 9m. So square root of 9, and then m is still 2. I can leave it as a square root as well, like that. Okay, just for now. So it's a square root of the whole thing. I'm breaking it apart just so we can see what it looks like. So 27 m to the 3/2 over square root of 9 is 3, and square root of m is actually m to the 1/2, right? If I write that as the kind of exponential form. So I can reduce this. 27 divided by 3 is simply going to be 9. And now 3/2 minus 1/2 is 2 over 2. So it becomes m, that's right, 3/2 minus 1/2 equals 2 over 2, which is the same as 1. So it's m to the 1st, and we're all done right there. Number 25. We rewrite this one here. We have 7 and 5/2 times, how do we write the square root of 7? On the denominator, it'd be a negative 1/2. The square root is the 1/2 because down below it's a negative. So now because of the same basis, I'm going to add the exponents. So 5 minus 1 is 4, and it's still over 2. 4 over 2 can be reduced to 7 squared. 4 over 2 is 2, and 7 squared is 49. And that's it for that one. Number 27, getting to the last one here. We can rewrite this as 6 to the 2/8 power times the base of 6 to the 1/4 power, but it's negative, right? I want to have a common denominator. So let's go ahead and I can reduce this actually. 2/8 can become 1/4 times 6 to the negative 1/4. Same basis, so now we add 1/4 minus 1/4, which is 0. And 6 to the 0 power is 1. And that's it for today. All right, that's it for it. We'll see you next time. Bye.